Welcome to another GCBASIC demonstration. This is about a change to the compiler. This is about data blocks. Let me give you the background to this problem. Let's look at a forum post in April 2023. It's from a guy called Manfred, and Manfred's currently testing what I'm showing you, so it's pretty good to show you. He said, I think that many people will appreciate a data statement. Lots of then a justification. People are coming from a pick basic plus because of the chips aren't supported, and he's having to stuff data into a hex file. He's written a little application, but wouldn't it be good to have it included? Let me show you it operating. This will make some sense to you. I'll show you. This is a putty terminal. I don't know if you can. This is just a power source. I'm using the PickKit Plus as a power source. Let me just turn the power on. And what it's doing, it's putting text on the screen. Let's zoom in a lot and we can then see it, okay? We can see it's putting text on the screen. Let me pull it down so you can see it. And it's paragraphs and paragraphs and paragraphs of data. And at the bottom, right at the bottom, let me put it at the bottom of the screen there so you can see it. It says the word end. And each section in here has got a number. It's got numbers 19, 18, 17 for those who are playing along, 16, 15. So something has put that on there, and it's clearly come out of the microcontroller. Let's have a look how I've done that. So basically what we have is a problem. We want to reference data. I've used a text file. It's a Latin text file. It's enormous. And in actual fact, interestingly, if I show you this and I read the file back in, the file itself is how many? Well, it's nearly filled the memory. That's 3EDF. There's only a couple of lines left, and that's full. That file is full. So we've managed to put and stuff a load of data in here. And I've used, as I said, text file. It could be any value. Okay. So have a look at how I've done that. So this is the compiler, also the IDE. And essentially what I've got is a brand new statement that I'm going to be sharing with you. And it's pretty standard. It's got the standard chip at the top. It's got the serial port, which we're just using. I'm only using the serial to demonstrate this to you. And there's a thing called block. And you just go data, you give the block a name, and you say it's a byte value or a word value. I'm using bytes. And it's put all this stuff, and there's a lot of stuff into the program memory. If we look at the assembler over here I've opened up the assembler. In the assembler, I just cursor down, there is pages and pages and pages and pages of assembler. And it's just translated that very quickly. And if I use the right-hand side of the IDE, I can see it goes right to the bottom. And at the bottom, we're pretty well at the top of this memory. Let's go back to our source program and see how we did it. So data block, give it data, a block name, and then as byte or word. And at the bottom, I've got end data, and that just sort of seals it off to say that's the end of it. I put FF at the end. Why have I put FF at the end? Because I'm going to use that as my end of file, just so I know I've got to the end of the file. So what I'm going to do is declare a couple of variables, offset and value. Offset is where I am in that data block, and the value is the returned value. I set my offset to 0 to start with, and I just put some serial stuff on the screen, on the terminal, and we'll just wait 100 milliseconds. Could be a lot less than that. Maybe, I don't know, you can play with that. But I'm using putty to display it. And then I'm using program read. I say at the block address, plus the offset. Get me the value. And it returns out with the value. So at block is the reference to the data block itself with an offset, which we increment by 1 each time we've read it. If the byte value is equal to FF, then exit this little loop I've written. Else, what it's going to do is put the value of that on the serial terminal. So if I compile that by I'm pressing function key F6. I'll zoom in for you. You can see that it's compiled it, and it says here it's build 1387. That's the one you need. It's compiled a block here. It says in here that it's successfully compiled it in 2 seconds. And it says here it's used 99.1% of the available program memory, and it's only used 21 bytes to do that. And you can change this sort of stuff around for those who play along quite a bit. You can change your compiler. You can do this if you wish with npasm. I'll just change that over to npasm. And so this is all compatible with the other compilers that we support. So it's going to compile the assembly. It's then passed it out to npasm, and it's actually compiled it back. And it says on the screen there, as you can see, it says that it's used npasm as your assembler, and it took just a short amount of time longer, but it's the same file. So what does that look like when we program it? Function key F5. It's just compiling it using npasm, using pitkit plus to program the file. If we come out to our terminal, I shall clear the terminal. I didn't clear it. Reset it. There we go. And it's just programmed it. I've turned the power off, so I've just put some power into it. So I'm going to use my pitkit plus to power it. And in the background, already, 1, 2 sections. The section numbers are now coming down the screen at high speed. Let's just get it all so you can see the whole lot. And then it says end. And that's what we had in our source file. Our source file had exactly that sort of construct. Let me just come back into here. So what we had in here was my data block. And at the end of the data block, it outputs the word string. And there's the string end. So the data block itself is extremely simple. You can insert strings, decimal values. As you saw, you can put hexadecimal values, calculations, all the standard things that you could do inside of EEPROM or tables, but it's now extremely large. As you saw in that diagram, you can see that that's a very large block of data, and then you can use that for reference data, graphics, or whatever you want to use it for. I don't know. It's been tested on all our compilers. Great. So, wanted to show you data blocks. Enjoy.